In this video we'll be getting onto the electronics pack for the ASR33. But before I do that, I just want to fit the parts that I've repaired so far back into the chassis, and also I just want to briefly explain this H-link business to explain how the printer and the keyboard interact. It's a very simple mechanism, and effectively it's a handshake line between the printer and the keyboard. So the printer and the keyboard take turns in controlling what amounts to a handshake line, as we would normally have in an RS232 interface. If I just rotate this slightly, you can see I've refitted the printer to the chassis. I didn't show that, it just sits down into its rubber mounts. There's no mounting screws or anything. Okay, so what we have is this H-link arrangement down here. And if you recall in a previous video, I had to hold this down to prevent the printer going into continuous print mode. So if I let go of it and I manually rotate the printer, then you'll notice that that lever, hopefully you can see it, just continually rocks back and forth. So it's going down, the printer is rotating, so it's going to print mode. If I go all the way around, you can see the printer going through a full print cycle, and then eventually this lever will rock back horizontal again, which is what it's doing now. Now if I hold this down in the horizontal position, then when we get to the end of the print cycle, so the printer's still turning, we're coming to the end of the cycle. So it's now at the end of the print cycle, but the clutch has disengaged, so it's no longer in print mode. It'll keep cycling, but it's not actually trying to print, it's not rotating the distributor. But if I let go of this, then again it goes directly into a print cycle and the distributor is now rotating again. So how does this work with the keyboard if it's rocking back and forth all the time? Well, if I grab the keyboard and we have a look at that. Okay, so on the keyboard, if we turn it around, on the back of it we have a matching link, and if I press a key you'll see that link will rotate. So it's now popped down. That enables the printer to go into print mode, but notice that this can be set back by the printer. However, once it's in this position, this will no longer move. So the other end of this is this little tab sticking out here. But once it's in its down position, its reset position, you can't then lift it. It won't, it's latched down, so you can't pull it back up again. In other words, the printer cannot now move this. It's basically held in this kind of horizontal mode, and the only way to make it go down again is to push another key, and then it pops back down. So in other words, when it's in the reset like this and it's horizontal, the only way it can be released is to press a key. So if I press a key, you can see it pops down. But now it's kind of loose, it's now under control of the printer, so the printer's doing a print mode, and in the end of the, or towards the end of the print mode, this will rotate back and it will go back down, resets the keyboard, but it latches down. So this is now holding the printer in its non-printing mode. In other words, when we push a key, it hands control to the printer. At the end of the print cycle, the printer hands control back to the keyboard. It's as simple as that. So to fit the H-link, so this is the H-link. It only really goes in one way around. You can fit it in backwards, unfortunately, but it's very difficult if you put it in backwards. So it just basically fits in these slots. You probably can't see it very well, but it goes into these slots at this end. There is a slot which you can use to help you refit it. The cutout goes towards the left, and I'll show you why in a few minutes. We'll just get the chassis back in front of the camera. Okay, so I've got you zoomed in. This is the H-link. I'm just going to rotate the printer until this is horizontal. It'll just make it far easier to refit the keyboard. Okay, so that's now horizontal. If we take the H-link, the reason the cutout goes on the left is because when you refit this, you have to pull this sprung lever across, and so the cutout portion is there to clear the post that this lever rides on, and then this will go down. You can release it and it pops back in, and then it's held captive. So If you use the slot, and you can kind of press this onto a large flat bladed screwdriver and it will hold it fairly well, and then you can align it and it's quite easy to install. The keyboard's held in place with two screws. There's one here and there's one on the other end, and then the front edge of it goes into slots on the front of the chassis. So I'll drop the keyboard in place. You just need to be careful as you put it in not to rest it on this plastic lever. That's possibly how it got damaged in the first place. And in theory it should all line up. I've taken the screws out, although there are slots on the keyboard. I'll take the screws right out because then I can see the witness marks on the keyboard and get it back exactly where it was before I took it out. Okay, I'm not sure I can do this with the camera in the way, but we'll give it a go. So to refit the keyboard, we align the two tabs at the front with the slots. Make sure they engage. You can feel it's now engaged, it won't move side to side. The back will then drop down. I'm just checking to make sure the screw holes are aligned, which they are, and that's it. All I have to do now is fit the two screws, and then we can refit the H-link. Okay, I've got you zoomed in as far as I can, but I don't know if you're going to be able to see this. So this is the sprung link on the printer, and then we've got the link on the keyboard. So we start off by attaching the H-link, and I just press it onto a screwdriver. Okay, I've now got this pressed onto the screwdriver. We can pass this very carefully down and try to engage it with the link that's on the printer. That's the sprung link. Making sure we've got it the right way around, of course. And if we get the angles correct, it will go on there fairly easily. So we're now engaged with the printer. I'll just take the screwdriver out so you can see it. So we're now engaged with the sprung link. I'll put the screwdriver back in to stop this popping out of the way. We can now push the lever across against the spring. It will then drop down, and we can now use the lever. There's a little tab at the front of the keyboard. We can now rock that about to get the angle of the link on the keyboard to match the current angle of the H-link. And when you get the angles correct, it should just pop into place. I'm just moving the link on the keyboard. And so, as you can see, it pops into place and it's now fully engaged. So we now have the H-link properly engaged. It's quite easy to get in there. You can see it only took a few seconds to get in. So engage it with the sprung lever on the printer first. Push it down so it's horizontal. It'll probably be resting on the lever on the keyboard. And then you can either move the little tab at the front of the keyboard to rock the plate that's on the keyboard, or you can rotate the printer and that will tend to rock the H-bar and the H-link. So the two are now properly engaged, and so I should find if I push the key down, it now engages the H-link. And what we'll do now is we'll hook it up to some power and we'll try and run it up and see if it does what it's supposed to. Okay, I've got it hooked up to the power supply. We'll turn it on. It'll be fairly noisy as ever, so this is going to do start up. But because it's now got the keyboard attached, we should find that the distributor doesn't just continually turn. It should only turn for one cycle when I press a key, and then the printer should pop the keyboard back into reset and the cycle should stop. So we'll power it up. Press the key. So just in case you can't see, I'll move the camera across a bit, power it back up. So you can see it's not going to print anything because it doesn't have the electronics pack, so there's nothing driving the main solenoid on the printer. but you can see that the printer control, the printer cycle and the keyboard are all doing what they're supposed to in terms of their interaction, so that appears to be good. One last thing I want to try is the here is link and see if that puts it into the here is cycle. So when we press the here is key, we should see it's a cycle for a few seconds and then stop. Which it does. Okay, so that's all working. We'll get this out of the way and I'll get the electronics pack onto the bench. Okay, well finally we have the electronics pack on the bench. This doesn't really do very much. It's really taking the signal coming from a remote machine, feeding that into this control. This board is the driver for the solenoid, so it takes small scale signals, uses a power transistor, and it uses that to control the solenoid when it's printing. We've also got power for the current loop and that sort of thing, and also the switch to put it into the different modes. So that's all it does. So you know what's coming next. I'm going to take this apart and give it a clean. We'll have a look at it and check for any damage. So we'll remove the bracket. That's interesting, that screw's loose, so maybe somebody's already been here. What we can do now is test this, test the power resistors, make sure they're okay, and as I say, I can now go through this, clean it all up, check for any damage, so we can take the caps out, or at least disconnect them, check for any leakage on these. So if we've got any leakage on these caps, we can check, look for any sign of damage, and if they're okay, we'll leave them. If not, we'll have to find replacements. I'll do the same with these caps down here, and there's another one on this board, but I'm only going to change them if there's any sign of damage. But the next step is to get this cleaned up, make sure that there's no obvious sign of damage to the insulation. So places like this where it's pressed against a square edge on the bracket, we need to check. Same down here, looking for any damage to the insulation. She looks okay. Okay, so I'll go and get this cleaned and see what we can find. I've been through the electronics pack and it seems fine. I've checked the capacitors for leakage. I've done a ground leakage test as well, and it all seems to measure out fine. I've also checked the components on the control board as much as I can, and they check out fine as well. So you can do quite a lot of testing on this. So for example, the power transistor that's on the heatsink here, you can quite easily test that with it in situ. You can disconnect the collector, and then we can do the usual static transistor test on this. And that seems fine. If we suspect any issues with that, we can of course take it out and put it in the curve tracer, but it seems to be okay. Okay, I've got the electronics pack hooked up to a power supply. I'm going to now slowly increase the mains voltage. I'm going to go up 10 volts at a time and then check the voltage on the two capacitors. And by the time we get to 120 volts, we should have between 16 and 20 volts across this cap at the back, and about 60 volts on the cap at the front. So we'll start off with 10 volts, measure the two voltages. I've got a current clamp on one of the supply leads as well, so I'm looking for any current spikes. That's fine, and that's fine. So we'll go up to 20 volts. Okay, that's fine. And that's fine. So I won't show this entire process, it's quite slow and tedious. When I get to 60 volts, I'm going to leave it for a few hours and just let it soak, make sure nothing fails, come back, recheck the voltages. And so I'm not going to video this because I have to turn the extractor on that's above this, and it's quite noisy, just in case I do get a failure. and assuming that there aren't any failures, I somehow doubt there will be, but assuming that it passes all these tests, I'm going to leave it running overnight, so it'll run for 24 hours. I'll put a small load on it, just a dummy load, and if that's all fine, then in the next video we'll get this bolted back into the ASR33 and see if the machine can actually print anything. With this fitted, we should be able to drive the print solenoid, of course, and then the whole machine should start coming to life. So in the next video, that's what we'll do, and that's it for this one. If you want to see more detailed testing like this, then please leave a comment. Otherwise, I'll skip through all the tedious stuff because it is a bit dull and does tend to go on for quite a long time.